This is part 2 of section 8.2. Right now we're going to talk about simplifying the fourth root of 6 to the 8th. Now we learned a method of doing this in the last section, and what we did then is we used, we recognized that we had property number 7 where we could rewrite something as a power raised to a power. So I could write this as, because 8 is equal to 4 times 2, I could rewrite this as the fourth root of 6 squared to the fourth. This is using properties from the last section. And then since we had the same exponent as index, we got what was inside. And so 6 squared is 36. Okay, so that's using what we learned in the last section. But there's another way of thinking about this, one that is actually probably easier to deal with. And I'm going to take this and I'm going to go backwards. Right now I have something in this form right here. And I want to rewrite it as a fraction. So my base is 6. Okay, A is the radicand right there. My exponent is m, so it's m over n, so 8 over 4. Well, 8 over 4 is a fraction. Just because it's an exponent doesn't mean it doesn't reduce. So this is 6 squared because 8 over 4 is 2. And so 6 squared is 36. Two different ways of thinking about it. This property is why this works. This power raised to a power property is why this works. They're all connected. They all follow directly from the meaning of an exponent. Okay, so let's look at simplifying this thing. Okay, now, after last section, we are told that our variables are always positive numbers, so we don't have to worry about absolute values anymore, okay? We will have a property that says that if I have the same kind of root on the top and the bottom, I can combine these back into a fraction, but I don't have the same root here and here, okay? And we know that when we are simplifying things with exponents and everything, one of the rules we have is that we cannot have a repeated base. And here we have a repeated t. So we are going to have to use this property along with these properties in order to get this thing simplified. The first thing I want to do in order to use all of these is I want to rewrite these using exponents instead of radicals. So remember the power over the index. So this is the same thing as t to the 4/3 over t to the 4/5. Power over index. Okay, so now let's look at these properties. We have a property number 4 that says if you have the same base, which we do, and you're dividing, you can subtract exponents. It's going to be the top exponent minus the bottom exponent. So this is the same thing as t to the 4/3 minus 4/5. Now you can use your calculator to do this, or you can go ahead and get a common denominator, which would be 15. So if I multiply this by a 5 and this by a 5, and then this by a 3 and this by a 3, I have t to the 20 over 15 minus 12 over 15. So this is t to the 8 over 15. I would reduce this fraction if I could, but it doesn't. They might ask for your answer in exponential form. In that case, you would leave it like this. But as a general rule of thumb, if you start off with radicals, they usually want your answer in radical form. Just pay attention to the little blue part beside the answer blank and make sure you give them the answer in the correct form. If exponential form, this would be okay. If they want us to go back to radicals, this is going to be a 15th root raised to the 8th power. So 15th root of t to the 8th power. Now, depending on how they want your answer, it will be one of these two. Okay, so let's look here. I want to simplify this, and I have fractions multiplied together, different bases. So if I have basically this situation right up here in the top. Okay, I have two things multiplied together. I'm not worried about them having exponents, but they're raised to an exponent on the outside. And since it's multiplication, I can use this. Remember, addition, subtraction doesn't work. I get to take this exponent and apply it to each one. So this is the same thing as x to the 1/4 times 20, to the 20th power, sorry. Y to the 2/5 to the 20th power, and this is over x squared. Now what we have is we have exponents raised to exponents, which we can multiply these together. Okay, now 20 times 1/4, what is 1/4 of 20? 5. So this is x to the 5th, y to the 2/5 times 20 over 1. The 5 and the 20 reduced to a 4. 2 times 4 is going to be 8. So that's y to the 8th over x squared. So the top is completely simplified now. All I have left is I have a repeated base here and here. And so I have property number 4 that says I subtract those exponents, top exponent minus bottom. 5 minus 2 is 3. So this answer is x cubed, y to the 8th. Okay. Now let's do p cubed to the 1/4 over p to the 5/4 squared. Okay. Now what we do is this is a power raised to a power, so we multiply those together. It's 3 over 1, so that top becomes p to the 3/4 over. Okay, that's 2 over 1, power raised to a power, so we multiply those exponents. And if I'm looking ahead a little bit, I can see that I'm going to have the same base, top and bottom, so I'm going to end up subtracting their exponents. I could multiply 5/4 times 2 over 1, reduce this, and get 5/2. That's perfectly okay. But if I don't reduce it, I get 10 over 4, and I'll have a common denominator. So I'm going to do that. Just looking ahead a little bit, I mean, if you could do it like this, and then when you go to subtract, you're going to have to create a common denominator. Either way, you're going to end up here. P to the 3/4 minus 10/4. Whether you reduce it and then get a common denominator, or don't reduce it and keep a common denominator. When you do that subtraction, you get p to the negative 7 over 4. And we started off with exponents here, so we're probably going to end up with exponents here. We do not keep negative exponents. This is the same thing as 1 over p to the positive 7/4. And that's likely what they're going to want you to leave your answer as. Okay? So let's look at this. R to the 3/4 times R to the 1/2 plus R to the 3/4. This is a distribution. This is the same pattern as this. Okay, don't worry about where I got those numbers. I just made them up. But this is exactly the same pattern. We have the same base all the way across, and we have 3 different exponents. Right here, you would not have much of a trouble recognizing that it's a distribution. That doesn't change here. So we are going to distribute. Okay? And you are probably not even thinking about this anymore when it's in this form, but what we have is this property. Multiplying things with the same base, we add their exponents. So we would do this. R cubed times r squared is r to the 5th. 2 plus 3 is 5. We're doing the same thing here. I'm going to write out this step completely. Since we have the same base all the way across, and we're going to distribute, what we really have here is r to the 3/5 plus 1/2 plus r to the 3/5 plus 3/4. Okay? Now you would need to get a common denominator and combine, or go ahead and use your calculators. 3/5 plus 1/2 is 11 over 10 plus 3/5 plus 3/4 is 27 over 20. Did I do that right? 3/5 plus 3/4. Okay, yeah, 27 over 20. Okay. All right, so let's look at this one. This one looks scary. It looks awful, but it's really not as hard as it looks. It's a square root of a cube root of a fourth root of x. What I'm going to do is I'm going to start on the inside and rewrite each of these with an exponent that is a fraction. Now, this is x to the first, so I'm not going to have to worry about the numerators. I'm just going to have to take care of the denominators. So I'm going to write this out step by step by step, just so you can see what's going on. I have the square root of the cube root of, this is going to be x to the 1/4. Okay, and I'll put this in parentheses to make it look a little bit easier. Now I'm going to take the cube root. So this is going to be x to the 1/4 to the 1/3. Now what do I do here? A power to a power, I multiply those exponents. So this is the same as the square root of x to the 1/12. Now this is the same thing as x to the 1/12 to the 1/2. Multiply those exponents, you get x to the 1 over 24, which is the same thing as the 24th root of x. Now in this case, you are just multiplying the indices. That's not always going to be the case because it's not always going to be to the first power here. So you can't use that as your rule. You could also have gone directly to this, x to the 1/4 to the 1/3 to the 1/2, and just multiply all those exponents together and you would get to right here as well. Not half as bad as it looks.